recording, so. All right. Okay, so like I said, we're just gonna start from scratch with this. And again, we don't have to go through all the nuances of the last session, but I'll show you just kind of the basics of where to get started. So first thing I want to do again is draw that baseline just so everything can match up nicely. So I'll use my polyline here. I'll get as close to that crosshairs as possible and draw a 3,000-foot line. So there's that. That way I can make sure that everything matches to those dimensions. The next thing I want to do is also draw my bounding box. I'm going to go to that layer. I should be able to use my smart track to just make sure that that's matching. So I'll click it right around there and do 3,000 by 3,000. The next thing I want to do is, again, start to populate this profile with some points. So I'll go ahead and go to my top view for that and start to place those. Obviously, you can do that through the more manual way, or you could, in this case, draw the profile for what it is. So it sounds like everyone gets the point of putting points. So I'm going to actually do it as a solid curve or solid profile for this part of the mountain. So I'm just, again, going to make sure that I start at the correct location, and now I can just give it here. And I can give it obviously a little bit more rigidness to it since I'm doing the entire profile. Luckily, it's not too detailed, so it shouldn't take that long to just kind of plot these points. So the way we're going to show how you can get quicker results, I can do it at a much higher resolution to get a lot more curves. Obviously, the more curves, the more information, the more that has to be processed. So it's really to your discretion on that. So we're almost there. I'll start kind of getting a little bit, and then I'll again make sure I go all the way to that end. So that looks good. And then I can even close it. So I'm going to just bring it all the way down there. Then I'm going to do one to close up this side. So I'll take all these red curves and join them. Go ahead and lock that. So just like before, I want to make sure it's actually rotated the correct way. So I'm going to type rotate 3D, not just the simple rotate. This baseline is my axis, my rotation axis. Now I can just hold shift to lock it in at certain intervals, in this case 90 degrees. So there is my profile standing right side up. I'm actually going to do that with also that bounding box. So let's rotate 3D again. Again, I'm just going to start in this corner, use that as my axis. So there we go. Yeah, that's fine. Now I can select my curve, this profile, and now I'm going to type planar surface. And so I'll change it back to being shaded so you can actually see that it is, in fact, a solid surface that we have in here. And from this solid surface, we can actually contour it, and that's going to give us all our main intersection points with the profile. So like I said, you can start to get a higher resolution depending on the contour intervals. So I'm going to type contour. Go to the correct layer first. I'm going to type contour. Base point, that's just at the bottom here. The direction, make sure it's going up. And then I'm going to say my distance between contours. In this case, I'll keep it somewhat simple at 50-foot contours. So it does it nice and quick. And now you've got all your points here. And like I said, you still probably want to include some specific points for these contour lines. So I'm also going to draw some points at those critical junctures where I want to make sure I still retain that detail of the landscape. I don't have to do a whole lot. Looks like that just missed it. But things like this where you have these kind of sudden changes in topography are going to be critical. So that should be good for now. I can just add one more there. Okay. So what I want to do now is migrate over to Grasshopper. So we'll get to the part where we're creating the surface, but for now, we'll go through these steps. And I know I breezed through it on Tuesday just to quickly show you an example, but the way this works is that you have this first panel here. This is how you bring in any type of geometry from Rhino into a Grasshopper. So this is how you reference that geometry into Grasshopper, and from there you get to start to manipulate it. I'm going to be referencing both these contour lines I created as well as these points. Because they're different geometry, they're going to need different reference components. I'm also going to delete some of this excess curves that I don't need. Let me lock this so I can just get rid of all those kind of contours that were too low. So I'm going to go ahead and reference that. That's pretty much going to get captured. I mean, let's just do it for the sake of consistency. So here's my contour curves. So in here, I'm going to go to my geometry. So that, like I said, this is where you reference any type of Rhino geometry. I'm going to select curve, bring it in here. If it's not processing anything, it's usually orange. So I'm going to right click it, go down to say set multiple curves. That's going to think, and now it's gray. When it's highlighted, it's green, and there you can see it's also highlighted in Rhino workspace. So like I said, I want these curves as well as these specific points. So let's go ahead and select them as well. Oops, I selected that too. So now instead of curves, I'm going to go back to geometry and say points, set multiple points. So they're being displayed as this X. So the last thing I need to do, because again, I'm going to be extracting from these points, just like how we did manually, lines. So these curves, I need to find their endpoints to generate those curves as well. So I need to take this one more step further. Whenever you start to analyze or extract data from certain geometry, you would most likely find that information in these other tabs. The first two are whenever you're doing any type of equation or calculations. Sets is how you start to organize data. So these aren't dealing with geometry specifically, but just the data that's contained. But then you start to get into the other things. So instead of points, it's called vectors or points and directions. There's your curve tab, there's your surface. So like I said, when you start to analyze and creating different geometry in Grasshopper, go to that respective tab. So in this case, like I said, I'm trying to get points from this curve. So I'm going to go to the curve tab and I'm going to go to analysis and choose the endpoints. So this is going to give me a points at either end. So both the start, that's what this S says, and the end. Again, if you're not familiar with Grasshopper, and you're wondering what all these different letters are at both the input of these components as well as the output, just hover over it and it'll tell you what it's looking for. So you can see it's looking for a curve. That's why that's plugged in there. And these say start and end, and the icon is that of the point component. Okay, so now we have all those points that we've plotted out manually that we can do the same thing shown in that scan. So from these points, I'm going to do a line SDL. This component essentially finds some type of point that you're referencing, and it's going to create a line from that point in any direction you want. So if I stay in this curve tab, I'll go to primitive and choose line SDL. So that's what it means. So start point, direction, and length. So the start point, it's both the start and the end point. If I just click, hold, and drag this over, it's going to replace that. So in order to drag multiple lines into these inputs, you have to hold shift. You'll see even the icon changes to like this green with the plus sign. So now they're all going to start from all those points. The direction, I do want them to go in the vertical direction. And when I look at this, I see it goes 0.0, comma 0.0, 1.0. So the way the vector works is that it really just works off of any number between 0 and 1 being kind of that absolute direction. So it's organized just like any coordinates. You have X, Y, and Z. So if Z has a 1 on, that means it's going up. If the first number has a 1 on it, it's going in the X direction. And then if it's in the second one, it's going in the Y direction. And then you can obviously have multiple, and that's where you start to get angles. But those are kind of those orthogonal vector directions. So the next thing I want to do is actually give them length. I think it gives it a default of 1, which you can see is just very microscopic. It's just barely there. I know that this purple bounding box is at least 3,000 feet. So I'm going to just give it an outrageous dimension and say 4,000. So I can just double click this screen and start typing anything I want to prompt. So now I've got a 4,000 slider. So now you can see that they're all going up 4,000 feet. What's good is that they're going to be overlapping with the box. However, you could see that I'm still going to have to actually rotate them and then lift them up all to their respective heights. If I follow that same principle of like just assigning a length, I can see that all the points are at their correct height, right? See, I see them all there. So what if I just decide to change the direction of these lines so they're going to take each of those points and shoot out? Let's give that a shot. So instead of going in the Z direction, I'm going to go in the Y direction. So if you're ever struggling to know what direction, you should have this world axis down here. So Z up, X is going to the right, and then Y is going to the top. So that's like plan view, X, Y axis. So now I want to actually give it a Y. So I go back to my vector, then I choose vector and choose unit Y. Now I'm going to drag it in there. And wow, look, now you've got all your lines in their correct height. Yay. In this case, I'm actually going to reduce their length to 3,000. So I'm just going to double click on this, hit 3,000 so that they are the correct length. And from here, I can start to generate my surface. So the next thing I'm gonna go a couple more steps starting in the next video, but this is pretty much as simple as it can get. So you can see how much more automated this version becomes versus having to trace, then move them all to their respective height, right? So this is a much more efficient way of starting to generate the service. There's a couple other ways I'll show you guys in terms of why we're doing it this way, which just yield different results, which isn't what I want. So I'm going to go ahead and just stop that there for that recording.